Okay, hello folks. This is your first Geology 1040 lecture that's got any content in it. So Geology 1040 is Physical Geology. I am your instructor, Dr. Jason Boettcher. Pronounced Boettcher, the O is silent. The G sounds like a CH. You can just call me Dr. B if you don't want to remember that. But Dr. Boettcher works too. So we are at Pellissippi State Community College, and we are teaching this in spring 2022. This is an asynchronous course, meaning that none of your lectures are going to take place at any set time. You will have some things like exams that you need to do over a certain period of time, but for the most part, you're not going to have anything due at a specific, that you have to be present for at any specific time. That's what asynchronous means, not at the same time. It's also an online course, so everything that we're going to do in here is going to be online. You should never have to come to campus for anything for this lecture course. Today, we're going to be talking about the Earth system. What do I mean by system? I mean that Earth is a group of interacting parts. System meaning interacting parts. And we will talk a lot about those individual parts, but I just want to give an overview with this lecture about some of those parts and about how we study those different parts in geology. Let me give you some examples here. So the Earth system, we can divide into subsystems like the atmosphere, or the lithosphere here, which is the solid Earth. Or down here, we see part of the hydrosphere and the stream and the body of water that it's running into. We can also see evidence of the biosphere over here, those green plants there. What else we got? The cryosphere. Over here, we see just a little bit of evidence of the frozen Earth. That's what cryosphere means. So anywhere that water is frozen. And these subsystems are going to interact in certain ways. We're going to learn a lot about those different interactions. And the fact that they're interacting means that one of them is affecting the other. And if you've got any changes happening, those are the interactions that make this really a system of parts that have effects on one another. For example, we've got this volcano here, which is a piece of that lithosphere, the solid Earth itself. And the volcano is erupting not only solids that you can see flying into the air there, but also gases and aerosols, which are sort of like tiny little dust particles, you can think of them as, into the atmosphere. And so it's affecting the composition of the atmosphere, it's affecting the temperature of the atmosphere locally at least, and on global scales, enough of these volcanic eruptions are going to affect the overall temperature of Earth. And that's an interaction between the lithosphere and the atmosphere. I have this picture here because we can think of the rocks that make up Earth, the lithosphere itself, in terms of three different types of rocks that we're going to be talking a lot about in the first part of this course. So igneous rocks, you probably remember from last time you learned about rocks, are those ones that formed from a melt. We've got metamorphic rocks over here that are affected by heat and pressure, but not melting. And then we've got sedimentary rocks forming over here, which are formed just by pieces of other rocks that have broken down, they've weathered, and they've been deposited somewhere else and re-lithified, turned into another solid rock. Anyway, that's just to get you started. You'll always see one of these starter slides that we'll begin with. And then you'll also always see in these lectures, you'll see a lecture outline. And this lecture outline will pop up throughout this lecture and allows me to divide up this lecture into bits and pieces to be a little bit more digestible. I don't want you all to have to sit here for an hour to an hour and a half to get through one of these lectures. So I tend to break it up into these subheadings. And each video is going to be one of these subheadings or sometimes less. So this first video is really only the first part of this lecture, and it's going to be on why we study geology. Over the next several lectures, we'll get to the other bullet points one by one, and we'll walk through what physical geology is and why we call it physical geology, what that physics has to do with anything. We'll talk about Earth as a system more explicitly, more than we just did. We'll talk about geologic time, and I'll just give you the briefest introduction to that and why that's important in studying Earth. We'll talk about geology as a science and what it means for science and the way that we actually do science and we use the scientific method to study phenomena on Earth. And then we'll lead into a discussion of Earth's interior that's going to be an important lesson in terms of how we know the things that we know about one part of Earth. What sort of evidence can we use in science to tell us about Earth's interior when we can't actually go there and look at it directly? Okay, so first, why study geology? There are lots of reasons, but one of the major ones that really forces us to think about geology are these natural hazards. For example, an earthquake. This is an image of an earthquake that occurred in Nepal back in 2015. It was a magnitude 7.8, and earthquake magnitudes really only go up to maybe 9.5 or 10 at the very most. We've only ever had earthquakes up to a 9 point something. So this is a pretty big earthquake, but it's not the biggest by far that we've ever experienced. And you can just look at this picture and see the devastation that's occurred on these buildings. That looks like they were built mostly out of wood or brick. And it actually caused 9,000 fatalities. If you're not sure where Nepal is, I'm going to do a really terrible sketch here. We've got Asia, and so we've got Southeast Asia there, India there, goes up into Saudi Arabia. Nepal is this very mountainous area between India and China that's formed because this plate, the subcontinent here, is actually pushing northward into the Eurasian tectonic plate. And we'll talk a lot more about that in the future. But the basic idea is you've got this physical pushing that's happening where India and China are pushing together, building these mountains, and also causing these earthquakes to happen here as well. That is what caused this particular earthquake and what causes a lot of earthquakes to occur in this region. So geology can tell us, one, that these earthquakes are going to happen in certain spots that are related to what's going on Earth's surface. Two, it can tell us places that we might consider building or not building in terms of avoiding some of these devastating natural hazards. And three, if we need to build in a place like this because we can't tell the citizens of Nepal that they've got to go live elsewhere, we can mitigate the damage that's caused by developing different ways to build our structures to resist some of this damage. So that's one reason to study geology. Natural hazards aren't just caused by the lithosphere, by things like earthquakes, but they can be affected by things that we don't normally think about as being related to geology, like high winds. So in this situation, we had these high winds in California, this atmospheric phenomenon that affected the hydrosphere. You can see these frothy waves down here because the wind is whipping up these waves, and it caused these cliffs here to erode tens of feet back. So these sediments were sort of piled up there, and wave action driven by the wind caused these cliffs to start to collapse. And you can see that it's really put at risk all of these structures, these buildings that are built here, and are really not going to be habitable anymore because of these disasters. So geology can tell us things like how often or how much at risk particular structures are on cliffs like this, how fast we might expect this erosion to occur in normal time periods, things like that. It can tell us about natural hazards that we don't see very often, maybe even over human history, but if they did occur, that they would be devastating. So what do we see here? This is a place in Tennessee, Cumberland City. You can see the Cumberland River right here. Got a Cumberland fossil fuel plant, so that's a power plant that's built there. And we see this ring of really low hills at this point right here. Geologic investigation has determined that this is actually an impact structure. And what I mean is that we had a meteor that came in, streaked in, and hit this spot about 200 million years ago. That's what 200 MA means. It's 200 mega annums, million years. So way long ago, 200 million years ago, this meteor hit at this spot in Tennessee, and it caused this impact structure. It was a crater at the time, probably, that was 7.5 miles across. That's huge. The meteor itself was probably much smaller, but still big enough to cause a whole lot of damage at the time. 200 million years ago, this would have been devastating to anything living in what was then Tennessee and really anywhere nearby. So we can study the rock record, looking at the rocks that are here that were laid down around 200 million years ago, to learn about what the environment was like before, what the environment was like after this happened, and maybe get a sense of what sort of devastation these events can cause. Not only natural hazards, but also natural resources are something that's important for us to use geology to learn about, because our way of life requires that we harvest natural resources, things like copper, that is being mined here at the Bingham Canyon copper site. This mine, I just want to give you a sense of scale. This is 0.6 of a mile deep, thousands and thousands of feet. You can see some of these tiny little yellow guys there. Those are dump trucks. They're not the small dump trucks either. They're the huge ones where the tires are like 2 people tall. So you can just get a sense of how huge this thing is. I also include this picture because you can see evidence that this was affected by its own sort of natural disaster. You see this big landslide that happened in 2013. Just look at how much Earth has moved to cause this huge landslide to occur. A knowledge of geology, first of all, tells us how and where we can mine this copper, and also tells us the best practices to avoid having something like this happen, so that it doesn't harm our resource gathering operations and it doesn't kill anybody in the process. Geology can tell us things about the environment. We live in the environment, we affect the environment, and the environment in turn affects us. So it's an important thing for us to learn about. So acid rain, it's this phenomenon that's part natural and it's part human-made. We might say anthropogenic. Break that down. Anthropo means people, genic, made, man-made. So it's part natural and it's part man-made. And this acid rain can do things like damage human-made structures, statues like this one that you can see in an early photograph. This statue had a face, and because of acid rain later, there's no longer a face on it. So this is just a natural, partially, process that dissolved the statue. So a study of geology can tell us why this particular stone that the statue was made of, why it was susceptible to acid rain, and it can tell us ways in which we can avoid contributing to that natural process and increasing the amount of acid that is in rain in the ways that we utilize different resources. In particular, we cause acid rain by burning especially coal, but also other fossil fuels that release more acid into the air. So if we are going to continue to do that, we need to know how we can mitigate that damage. Why else study geology? It can explain sort of big picture Earth properties. If we look at this image of Earth taken from Google Earth, we can see a couple things. First, we can see that it's separated into continents like Africa here, and Europe and Asia, and oceans. And those things are separate. It's not like we have a bunch of small islands or like a bunch of lakes just dotting on Earth's surface, but it's separated into continents and oceans. And why is that the case? We're going to learn about that pretty early on in the course, why it seems like Earth's surface separates into higher continents and lower ocean basins. What about separate forests and deserts? We can see this is roughly the equator right there. Why does it seem like the green areas group somewhere around the equator? So this is rainforest, tropical rainforest. This is roughly where Congo is. North and south of that, we end up with these desert belts. So we've got the Sahara Desert here. Why is it the case that it seems like this belt of deserts continues all the way around the planet? And then above that, we've got the temperate region where a lot of people live in Europe, say, and then above that, you can just barely see it, but frozen Greenland is right there. And certainly Northern Europe is also very cold. So why is it so cold up there? We can learn a lot about that by studying geology and related processes, and especially by thinking about Earth as a system. We can also study our own and come to understand our own place in the universe. So this is a picture from the Hubble telescope. So for a long time, our most powerful telescope in space, and it's not affected by the atmosphere because it's sitting out there in space, so it can see all sorts of really cool, faraway things. This is the Hubble Deep Field. And almost every object that you see in this deep field photograph is a galaxy. Tens, hundreds of millions, billions even of light years away from us. So each one of these galaxies here holds hundreds of millions to billions of stars. And so each of those stars can have many other planets around it. We're starting to understand just how many exoplanets are around the stars that are near us. So thinking about just how tiny our own planet is, this pale blue dot that we live on, and understanding how far away some of these other places are, and understanding that there is no other planet that we can get to and survive on yet. Thinking about these sort of things, we can use geology to study a lot of those and to learn not only about what's going on Earth now, but also going way back deep time into the past, over the past hundreds of millions to billions of years that Earth has existed.